Hello everyone. This video is on the Knewton Alta assignment for section 3.3 part 1 called Solve Coin Word Problems. Alright, so in this video I'm going to be going over a preview version of this assignment. So please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, the structure should be similar, so I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. Alright, so on the assignment page you should be seeing the title, the mastery bar telling you how far along you've gotten, the objectives, right, looks like there's only the one objective here, solve coin word problems. Under the objective you have a question related to that objective, and at the bottom of every question you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button, right? This is for instructors only. But you will have a more instruction button. Alright, so if you're ever struggling with a topic, just click on this and you'll be taken to a page with some reading to do or some videos to study, and then you'll be given questions related to that instruction, and completing those questions is another way to help you get through the assignment. Alright, so as I mentioned, the only objective here is solve coin word problems, right? Involving nickels, dimes, quarters, pennies, and so on. Alright, so as with any other word problem, I'm going to approach these the same way I have been in previous videos, previous sections. You read through the problem, you identify your unknowns, you name them with some variables, and I'm going to try to keep the number of variables to a minimum, right? Probably just one variable in all my expressions, and then you translate into math. Now that's always the hardest part, right? Translating into an equation. Because sometimes when you translate, it's also going to be assumed that you know certain things. Like, for instance, it's going to be assumed that you know how much a dime is worth and a nickel is worth. Dime is 10 cents, or 1/10 of a dollar. A nickel is 5 cents, or 5/100ths of a dollar, 1/20th of a dollar, and so on. So very often in problems, when you translate into mathematics, some background information is assumed of you. So that is also what makes it tricky sometimes. And then once you've translated into an equation, you solve that equation and use the solution to answer the question, and of course check your solution when you're done. Alright, so here we have, John has $2 in nickels and dimes in his drawer. The number of nickels is 3 times the number of dimes. How many of each are in the drawer? How many nickels, how many dimes? And then pay attention to the boxes here when you're entering your answers. Notice it's a blank in front of the word dimes, so that's how many dimes you should be entering, right? And then a blank in front of the word nickels. Alright, so I'm going to go to some paper here, write out the information. We have $2 in nickels and dimes. Now they said the number of nickels is 3 times the number of dimes. I'm just writing the information we were given. So how many of each are in each drawer? So that's what they're asking for. We're asked for the number of nickels, which I don't know, and the number of dimes, right? Something I also don't know. Now, based on this statement here, the number of nickels is 3 times the number of dimes. I'm going to call the number of dimes something. I'm going to call the number of dimes, say, D for dimes. Now, you could call the number of nickels N for nickels, but we're trying to keep the number of variables to a minimum here. Use the relationships that were given to us. We're told the number of nickels is, right, the number of nickels equals 3 times the number of dimes. That would be 3 times D. All right, so if the number of dimes is D, the number of nickels is, 3 times D, 3 times the number of dimes. Now, we are told we have, $2 in nickels and dimes. So this is where the background information comes in. Remember, I said this out loud, but a nickel is worth, $0.05, right? If we're talking dollars. A dime is worth $0.1 or $0.10, 10 cents, a tenth of a dollar. This is some background information that they're assuming that you know. So if you take the amount of money John has in nickels and then add to that the amount of money in dimes, you get $2, right? So the amount of money, I'll write this in words for the first problem here. The amount of money in nickels plus the amount of money he has in dimes should be equal to $2. This is where our equation's coming from. Now, the number of nickels he has is 3D, but that's not all I'm putting here in this first term. That's the number of nickels he has, but how much money that's worth is 0.05 times that. Right? You take 5, each of these nickels is worth 5/100ths of a dollar. So I multiply those. If I had 5 nickels multiplied by 5 cents, you have 25 cents, $0.25. And you multiply those to get the amount of money John has in nickels. Same thing for the amount of money in dimes. He has D dimes, but each one of those is worth $0.1. So I multiply that by 0.1, right, or 0.10. And this should be equal to 2, right, $2, right, if I kept everything in dollars. Right. And then we go about solving this equation for D, and then using that solution to answer the questions, figure out the number of nickels and dimes. Now, if you can keep things in decimal form if you want. 3 times 0.05 here, that'd be 0.15, right? 5/100ths times 3 would be 15/100ths. So I have 0.15D for the first term, plus 0.1D or 10D for the second term, the amount of money in dimes. This should be equal to 2. These both have D in common, so I can combine them. 0.1 plus 0.15 is 0.25. And then equals 2, and then if you, equals 2, and then dividing by 0.25, right? So 2 divided by 0.25, which if you multiply by 100 in the numerator and denominator, that'd be 200 divided by 25, which is 8. Right? 8. So D equals 8. That's going to be, remember what D represents, that's the number of dimes John has. Meaning that the number of nickels, right, remember the number of nickels is 3 times D, or 3 times 8, that'd be 24 nickels. And there's your answer, right, that's what they want. There are 24 nickels and 8 dimes. And then check your answer, of course, make sure it makes sense. Now if you had 24 nickels, how much money would that be? Well, that'd be $1.20, right? Each one of those is worth 5 cents. 0.05 times 24 would be 1.2, right? So $1.20 from the nickels, and then each dime is worth 10 cents, right? So this is 80 cents. $1.20 plus 80 cents would be $2 total. So this checks out. So there are 8 dimes and 24 nickels to make the $2. That's what all these problems are going to be like, right? They might involve nickels and dimes, quarters and pennies, whatever, right? But they'll involve coins. You just have to remember how much each coin is worth. That's going to be key. All right. Next. All right, so this is another nickels and dimes problem. So it's pretty similar, right? Carolyn has $2.55 in her purse in nickels and dimes. The number of nickels is 9 less than 3 times the number of dimes, right? So since they gave nickels in terms of dimes, I'm going to call dime something and then use that same letter for the number of nickels in some expression. Find the number of each type of coin. So back here, same kind of, I'll just write out the information we're given. Caroline has $2.55 total in nickels and dimes. Now I'm going to call the number of dimes again. I'm going to call that D again. And they said the number of nickels was 9 less than 3 times the number of dimes. So here's 3 times the number of dimes, 3D, and then 9 less than that, right? So minus 9. And then the same concept. The amount of money she has in nickels plus the amount of money she has in dimes should be equal to this $2.55. So you take the number of nickels, right, 3D minus 9, and that gets multiplied by, 0.05, right? There's $0.05 in a nickel. Add to that the amount of money she has in dimes, right? You take the number of dimes, which is D, and multiply that by 0.1 or 0.10. And then add the money up. She has $2.55, 2.55. Now, if you want to get rid of the decimals right now, you can. If you multiply both sides by 100, remember you can clear decimals. Multiply this term by 100, that would make this 5 times 3D minus 9. Plus, multiply this term by 100, that makes this 10D. And then over here, this would be 255. So basically, you changed everything from dollars to cents, right? Each nickel is worth 5 cents. Each dime is worth 10 cents. And $2.55 is, 255 cents total. And then we solve for D here. Right? Maybe it's a lot cleaner looking without the decimals. It's up to you, really. You can keep things in decimal form if you wish. All right, so I'm distributing the 5. That'd be 15D minus 45 plus 10D. Then equals 255, and then combining like terms over here, we have 25D minus 45 equals 255. And then I would add 45, making this side 300 equals 25D, and then dividing both sides by 12. Dividing both sides by 25 gives me 12. All right. So there are 12 dimes. Right? That was what D represented. And then replacing D with 12, 3 times 12 is 36. 36 minus 9 is 27. There are 27 nickels, right? And this is what they're asking for. Number of dimes and nickels. And then just double check it. 27 nickels, right? That would be $1.35. 12 dimes would be $1.20, and then add those up, you would get $2.55. So that number of dimes and that number of nickels works. So 12 dimes, 27 nickels. Wonderful. Again, please read through the answer explanations, just to understand why you got something right or why you got something wrong, and maybe you can learn from your mistakes for the future. Alright. Alright, so this one is quarters, dimes, and nickels. Ooh. Alright. So 3 coins, 3 types of coin. So mukel, I'm sorry if I'm mispronouncing that, but somebody has $3.75 in quarters, dimes, and nickels this time in his pocket. And then some descriptions. He has 5 more dimes than quarters and 9 more nickels than quarters. All right. So how many of each coin are in his pocket? Now, since they gave the dimes in terms of quarters and the nickels in terms of quarters, I'm going to call quarters some variable and then use that variable for the other unknowns. So once again, writing out the information here. So total of $3.75 in his pocket. And as I mentioned, I'm going to say, let's say the number of quarters is Q for quarters. Right. Now they said the number of dimes was 5 more than quarters. There are 5 more dimes than quarters. So it's the number of quarters, plus 5. That's how many dimes he has. And he has 9 more nickels than quarters. Right, so the number of nickels is, the number of quarters plus 9. Right? Q plus 9. Alright, and then how many of each coin does he have? Right, how many quarters, how many dimes, how many nickels? So again, I'm using the money thing. Now quarters, remember quarters are $0.25. They're a quarter of a dollar, 25 cents. So the number of quarters times 0.25, right, that's how much money he has in quarters, plus the number of dimes, this Q plus 5, times 0.1, right, that'll be how much money he has in dimes, plus, and then the number of nickels, Q plus 9, times 0.05, right, that's how much money he has in nickels. Add up all these monies, and he has a total of $3.75, 3.75. Alright, now once again, if you don't like the decimals, we can get rid of them right now by multiplying everything by 100. Each term, multiply each term by 100. That makes this term 25Q, and this term 10 times the quantity Q plus 5. And then this term 5 times the quantity Q plus 9 equals, and over here is 375. So basically, again, multiplying both sides by 100 just changes it from dollars to cents. Right, there are 25 cents in a quarter, 10 cents in each of the dimes, 5 cents in each of the nickels, and 375 cents in $3.75. Right. All right, so I'll distribute the 10 now. Distribute this 5. So we have 25Q plus, then you have 10Q plus 50 plus 5Q plus 45 equals 375. Add up the Q terms. That's 40Q. Alright, 25Q and 10Q and 5Q is 40Q. 50 and 45 is 95 equals, and then 375. Right. And then subtracting, subtract 95, and we have 40Q equals 280. Right, 280 plus 95 is 375. And then dividing both sides by 40, Q equals 7. So that's the number of quarters. Remember what Q represented. Right, there were 7 quarters. The number of dimes is 7 plus 5 is 12. There are 12 dimes. And there were 9 more nickels than quarters. So 7 plus 9, 16 nickels. And this is what they want. Right? 7 quarters, 12 dimes, 16 nickels. And let's check that. Let's just make sure the totals work out. Now if you have 7 quarters, that'd be $1.75, right? 12 dimes would be $1.20, and 16 nickels would be 80 cents. And if you add those up, that's $2, $3.75. Those add up to $3.75. So that works out. So 7 quarters, 12 dimes, 16 nickels based on their description. Great. All right. And one more of these. All right, so back to a problem with just 2 coins, just nickels and dimes. So Julio has $2.75 in his pocket in nickels and dimes. The number of dimes is 10 less than twice the number of nickels. So this time, since they're giving me dimes in terms of nickels, I'm going to call nickels some letter this time and use that for the dimes expression. Find the number of each type of coin. All right. So very, very similar problem for all of these, as you've noticed, I'm sure. So we have $2.75 total. This time I'm going to call the number of nickels something, some letter. So how about N for nickels? And they told us the number of dimes Julio has is 10 less than twice the number of nickels. So if we took twice the number of nickels, 2n, and then subtract 10, that's how many dimes he has. And then find the number of each coin. So again, we're going to go write a money equation. He has n nickels, and each one of them is worth $0.05, right? So multiply by 0.05, that's how many dollars he has in nickels. Plus, he has 2n minus 10 dimes. Multiply that by 0.1, and that's how much money he has in dimes. And you take the money he has in nickels plus the money he has in dimes, add it up, you should have $2.75. Alright, and then once again, if you want to, instead of working with dollars, you want to work with cents, multiply everything by 100, it's 5 cents per nickel, so 5n, 10 cents per dime, so 10 times 2n minus 10, and then this $2.75 would become 275 cents. Right? If you want, you can multiply everything by every term by 100, just to get rid of the decimals. Alright, so here I'd be distributing the 10, we have 5n, plus, and then 20n minus 200, minus 100, sorry, 10 times 10 is 100, equals 275, right? And then we'd have 25n on the left, and I would add 100 to give me 375 on the right, and then divide both sides by 25, n equals 15. Yeah, because 12 times 25 would be 300, and then you have 3 more, right? 15. Okay. So the number of nickels is n, right? That's 15. And then the number of dimes is twice n, so 2 times 15, 30, and then minus 10 would be 20. So 15 nickels, 20 dimes. And let's just check that out, just to make sure. Now for the nickels, if you had 15 nickels, that'd be 75 cents. Right, 50 plus 25, 75 cents. And the 20 dimes is $2. and put those together, you got 275. That totally works. That totally checks out. So 15 nickels and 20 dimes. Now be careful, they have dimes first, so 20 dimes and 15 nickels. Let's make sure you're putting the numbers in the correct slots. Okay, great. And again, don't forget to read your answer explanations. And that should be it for this preview version of this assignment. As I said at the top of the video, the questions I saw here may not be the same questions that you see when you work on the assignment yourself, but the objectives are the same, the structure is similar, so I'm hoping that watching me do these here helps you in some way when you work on the assignment on your own. And thank you very much for watching.